Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard to 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in this particular video, this will be the last video on gravitation chapter where I will be explaining the question 17 till the question 22. Coming to the 17th question in this particular exercise, here there is a building which is 100-meter high. So from the top of this building, that is from 100-meter height, so the height of this particular building is 100 meter. So from this particular height, a stone is dropped. So let's say a person is standing on this building and he throws a stone from this particular height. And from the ground, there was one more stone which was thrown vertically upwards like this. One particular stone is coming from the top and the other stone is coming from the bottom. So at a certain point, these two stones meet each other. So now you have to say what is the distance, or from starting from the top at what distance, or from starting from the bottom at what distance these two stones meet, and after how many seconds or how much time these two stones meet. Here the data which they have given is 100 meter is the height of this building. That means this stone, the first stone which is dropped from the building's top, that building is having 100-meter height. That means that stone is dropped from the 100-meter height. Now the stone which is projected vertically upwards, which is thrown vertically upwards, that stone was given 25 meter per second as the initial speed. So now here you have to consider two different initial speeds and two different final speeds. You have two different cases, that is stone 1 and stone 2. So let us call this particular stone as stone 1 and this particular stone as stone 2. So initial velocity of stone 1 will be 0 and initial velocity of the second stone will be 25 meter per second. So initial speed of stone 2, so I am calling this as U2. U2 means initial speed of second stone. U2, that is the stone which is projected vertically upwards, which is thrown vertically upwards from the ground. So U2 is equal to 25 meter per second, and U1, that is the initial speed of the stone 1, is 0. Here one particular stone from top is coming and another stone is also coming from the bottom. So at certain point these two stones cross over each other. So you have to calculate at what distance these two stones are crossing over or meeting each other. So in order to calculate this particular distance, you have to consider, so at this particular position, this stone will be having V1 as its final speed, and at this particular position this stone 2 will be having V2 as its final speed. So that means here final speed of stone 2 at that particular position is V2 and final speed of stone at that stone 1 of that particular position in that particular position is V1. So now we don't know what is V1 and we also don't know what is V2. So now in this particular question, we will call height as h. So height of the building as h, which is equal to 100 meter, and we will call the position at which these two stones meet as h1. So we don't know what is h1. So that means here one stone is dropped from the top of this building and one stone is thrown upwards from the bottom surface. So at a particular position these two stones meet, and this particular position we call this as height h1. So now we have to calculate what is this h1. So in order to calculate that, now we have to consider the first case. Let us consider the second equation of motion, that is S is equal to ut plus half gt square. So g I am taking because here acceleration due to gravity comes into picture. So this is the second equation of motion and we are considering this particular second equation of motion. So now we will write the second equation of motion for the first stone. So now if you are considering this as the building, and from this building top a stone 1 is released. So this stone 1 travels certain distance and it reaches somewhere here when the second stone meets this particular first stone. So here second stone is also thrown upwards. So at this position this stone 1 meet stone 2. So this is stone 1 and this is stone 2. Now this particular distance it has traveled. So this particular distance this stone 1 has traveled, and this particular distance has been traveled by stone 2. So this is h1. This is the height h1. The total height of this particular building is called as h. So that means here distance traveled by first stone. So distance traveled by first stone. So distance traveled by first stone is equal to h minus h1, because here it has traveled this particular distance. The stone 1 has traveled this particular distance. Here the total height of this building is h, and h1 is the distance at which these two stones meet. So if you subtract h1 from h, that will be the total distance traveled by that stone 1 to reach that h1 position. So that's why distance traveled by first stone is h minus h1. Why I am considering this is because in second equation you have to consider the distance traveled. So here S indicates distance traveled. So this is distance traveled. So that's why I am calculating distance traveled by first stone. So distance traveled by first stone is h minus h1. Now we will write second equation of motion for first stone. So now we will write second equation of motion for first stone. So what will be the second equation of motion for first stone? So here distance traveled by first stone will be h minus h1, which will be equal to, so now if you write the second equation of motion for first stone, that will be equal to h minus h1, that is the distance traveled by this particular first stone while meeting that particular second stone, and u1 is the initial speed of the first stone, and t. You cannot consider t1 and t2 because at the same time these two stones are meeting at a particular position. So that means time is same for both the stone. So that means to reach that position this stone has also taken some time, and in the same time that stone also covered certain distance and it has met with this second stone. That means time taken by both the stones are same, but distance traveled might be different. The first stone might have traveled lot of distance and second stone might have traveled less distance, but time remains constant for both the stones. So that's why instead of t1 I am just taking time t, and for second stone also I'll just consider time t. Here second equation of motion for first stone is h minus h1 is equal to u1t plus half gt square. We all know u1 is equal to 0 because stone is dropped from a particular height. So initial speed of that stone was 0. So u1 is 0. So this entire term becomes 0. Now what is remaining? Only h minus h1 is equal to half gt square. Here plus g will be there because it is coming towards the earth surface. It is traveling towards earth surface, hence positive acceleration due to gravity will be there. So h minus h1 is equal to half gt square. Now you have to write second equation of motion. So now second equation of motion for second stone. So now you have to write second equation of motion for second stone. So call this particular equation as equation 1. Now you have to take second equation of motion for second stone. So what is the height or the distance traveled by second stone? Here in this image you can see this particular second stone has traveled h1 height. So this h1 what is there is the height from the bottom surface. So here for first stone we took h minus h1 so that we get this particular distance, but for stone 2 we have to take this particular distance because it has traveled from the bottom surface. So that distance is h1. For first stone it was h minus h1, for second stone it is just h1. So second equation of motion for second stone will be h1 is equal to u2t plus half minus g t square. Why I am taking minus g is because here the second stone is traveling against the gravitational force. So that's why negative acceleration due to gravity will be applied on that stone. So half into minus g into t square will be there. So now we are getting equation as h1 is equal to u2t minus half gt square. So let us call this as equation 2. Now again we will write equation 1. So what was equation 1? Here you can see h minus h1 is equal to half gt square. So equation 1 I am writing here again. So h minus h1 is equal to half gt square. So here in this first equation we will take this h1 to RHS and this particular term to LHS. Then h minus half gt square is equal to h1, because minus h1 when it comes to RHS it will become plus h1, and plus half gt square when it is brought to LHS it becomes minus half gt square. So that means here we are getting an equation h1 is equal to h minus half gt square. So now let us call this particular equation as equation 3. So now we have got h1 is equal to u2t minus half gt square as equation 2, and we have got h1 is equal to h minus half gt square as equation 3. So if you compare equation 2 and equation 3, you have h1 and h1 in LHS. So that means here LHS and LHS are equal, so RHS should also be equal. So that means u2t minus half gt square is equal to h minus half gt square. Now you can just keep h here itself, minus half gt square. This particular term you can take to RHS. So then your equation will be u2t is equal to h minus half gt square. This half minus half gt square you are bringing to RHS, so it will become plus half gt square. So here plus half gt square and minus half gt square and plus half gt square is getting cancelled with each other. So you'll just have h on the right hand side. So that means here u2t is equal to h. So now you know what is u2t. Now you know what is u2. u2 is the initial speed of the second stone, and what was that? That was 25 meter per second, and height of this building was 100 meter. So you can substitute that, both are in SI units, so directly you can substitute the values. 25 into t is equal to 100. So you can bring this 25 to RHS. So t is equal to 100 divided by 25, which is equal to 4 seconds. So that means after 4 seconds these two stones are meeting with each other. So time is 4 seconds. Now here they have asked when they have reached. When they have reached means after 4 seconds they have reached. So now we have got the time. So we have got the answer for the first question, that is when they have reached. So they have reached after 4 seconds. Now you have to calculate where they have reached, at what position they have reached. So in order to calculate at what position they both are meeting, we can consider the third equation. So what was third equation? Third equation was h1 is equal to h minus half gt square. So now we are calculating what is h1. So h1 is equal to h is 100 meter, 100 minus half, g is 9.8 meter per second square into t is 4 seconds. So 4 square will be there. So h1 is equal to 100 minus 1 by 2 into 9.8 into 4 4s are 16. So now if you calculate this, h1 is equal to 100 minus 78.4 will be there. So now you are getting H1 has 100 minus 78.4. So 100 minus 78.4 is 21.6. So 21.6 meter will be there. So this 21.6 meter is the distance from the bottom. So here 78.4 meter from the top of the building. So 78.4 meter from the top of the building, or 21.6 meter from the bottom. So from the top it is 78.4 meter, from the bottom it is 21.6 meter. So this also you can write, or this also you can write, but don't forget to mention from where. So either from top or from the bottom. So 78.4 meter if you are writing as answer, then you have to write from the top. If you are writing 21.6 meter, then it is from the bottom, because distance traveled by first stone is h minus h1. So h1 is 21.6. So 100 minus 21.6 is 78.4. 78.4 is the distance traveled by stone 1, and 21.6 meter is the distance traveled by stone 2. So that means here this is distance traveled by stone 1. Distance by stone 1. So this is distance traveled by stone 1. This is distance traveled by stone 2. Distance traveled by stone 2. So that means here stone 2 has traveled 21.6 meter from the bottom, and stone 1 has traveled 78.4 meter from the top, and they have both reached at this particular position. Either you should say 78.4 meter from the top or 21.6 meter from the bottom. So here in the textbook, if you refer for the answer at the end of the textbook, there they have given 80 meter from the top. They have given 80 meter from the top. Why? Because here they have considered 10 meter per second square as the acceleration due to gravity. If you put 10 meter per second square in the place of 9.8 meter per second square, then in the place of 78.4, you will get 80 meter as your answer. But here in the question, they have not mentioned the acceleration due to gravity should be taken as 10 or 9.8. So when they have not mentioned anything in the question, then always you should take 9.8 meter per second square as the acceleration due to gravity. Only if they have specifically mentioned that take the acceleration due to gravity as 10 meter per second square, then only you can take 10 meter per second square. Or else you should not take 10 meter per second square, you should directly take 9.8 meter per second square. So if you take 9.8 meter per second square, then your answer will be 78.4 meter from the top. If you take 10 meter per second square, then 80 meter from the top. So this answer you will get when you take g as 10 meter per second square. This answer you will get when you take g as 9.8 meter per second square. So that's why in the answer section they have given 80 meter from the top. That means they have considered 10 meter per second square as the acceleration due to gravity. But you should not consider 10 when they have not given what to consider. They have just asked this question where they have not mentioned the acceleration due to gravity value. Hence you have to take 9.8 meter per second square, and if you are taking 9.8 meter per second square, then 78.4 meter is the answer. So 78.4 meter from the top or 21.6 meter from the bottom. These two stones have met each other. So coming to the 18th question, a particular person has thrown a ball vertically upwards. So this ball has traveled to certain distance vertically upwards, and then it has returned back to this particular person. So that means it has traveled this particular distance and it has returned back to the same thrower's hand. So the total time here taken is, so the total time taken by this particular ball, or here they have given ball, so total time taken by this ball is 6 seconds. So that means here 2 times the t is equal to 6 seconds, because the small t here, the small t is the time to reach maximum height. So time to reach maximum height is equal to time t, small t. Now from that maximum height, it has again traveled back to the thrower's hand, and it has taken total 6 seconds to come back to the thrower's hand. That means here 2 times the time you have to take, because the time t what it has taken to reach the maximum height, the same time t it will take to reach back to the thrower's hand. So 2 times the time t is equal to 6 seconds. That means it has taken total time as 6 seconds. So the total time is 6 seconds, or 2 into small t is equal to 6 seconds. So coming to the first question in this 18th question, here the velocity with which it was thrown up. That means here you should find out the initial speed of the ball. So this is the position of thrower. From this particular position, he has thrown the ball vertically upwards, height h. Now, in order to calculate the time taken to reach that maximum height, you can just take this particular equation, that is 2t is equal to 6 seconds. So t will be equal to 6 by 2, that is equal to 3 seconds. So the time taken for this particular ball to reach this height is 3 seconds. So that means it has taken 3 second time to reach, and it has taken 3 second time to reach back to the thrower's hand. So total time is 6 seconds. So in that, to reach the maximum height, it has taken 3 seconds. So now you have got time, and when it reaches the maximum height, it will stay there for few milliseconds, and then it will fall back to the thrower's hand. So that means here final speed will be 0. So now we don't know what is initial speed. We know that final speed is 0, and we have time 3 seconds. And here acceleration is acceleration due to gravity, but you have to take minus g because the ball is traveling opposite to the gravitational force. Now we can take the first equation of motion, that is v is equal to u plus minus gt. In the place of a, I am taking minus g. Now here v is 0, so directly v I can write this as 0. So now we are here getting 0 is equal to u plus at, or in the place of a I am writing minus gt. So 0 is equal to u minus gt. This particular minus gt you can take to LHS, it will be gt is equal to u. So now u is equal to, in the place of g I can take 9.8 meter per second square, because here they have not given any kind of acceleration due to gravity value. So at that time I can straight away take 9.8 meter per second square as acceleration due to gravity, into time taken is 3 seconds. So u is equal to 9.8 into 3. So 9 3 is 27, 8 3 is 24. So 29.4. So the initial speed at which this ball was thrown is equal to 29.4 meter per second. So now considering the B question in this 18th question, here they have asked the maximum height which it reaches. So in order to calculate maximum height, you can use second equation of motion. So second equation of motion is nothing but distance s is equal to ut plus half at square. So in the place of s, I will take height, because height is the distance traveled by that particular ball. So h is equal to ut plus half at square will be there. So in the place of a, I will take minus g t square will be there. So now you have to calculate the height, which is equal to, now you know what is the initial speed. So initial speed is 29.4, and time taken is 3 seconds, plus half minus 9.8. In the place of g you can write minus 9.8 into t square is there. So t square is 3 into 3. So now you have h is equal to 29.4 into 3. So 29.4 into 3 is 87 plus 1.2. So that is 88.2. So 88.2 minus 1 by 2 into 9.8 into 3 into 3 is 9. So now if you calculate this, so 88.2 minus 44.1 is equal to 44.1 meter. So that means maximum height which this ball has reached is 44.1 meter. Now coming to the C question in this particular 18th question, here they have asked its position after 4 seconds. So now you should be careful. Why? Because here this particular person who has thrown the ball, it has just taken 3 seconds to reach the maximum height. So it has taken 3 seconds to reach the maximum height. After third second, the next 3 seconds it is falling towards the earth surface. So now here after 4 second means, so after 4 second refers to 1 second after it started falling down. So after it started falling down, you have to take 1 second, because here it has taken 3 seconds to reach that particular height. After reaching that height, so next 3 seconds is the time which it takes to fall back. So after 4 seconds means 3 seconds it has went to the maximum height, and after 1 second it has come somewhere here. So now we have to find out that particular position. So in order to calculate that, you have to consider the distance traveled by that particular ball from the highest position to that particular position, and time will be 1 second. So here 1 second is the time which you have to consider after it started falling down. So after it started falling down. So that means here new time, I'll call this as time t1, that is 1 second. Now you have to calculate position. So in order to calculate that position, you can just call that as h1. So here h1 is equal to the distance from the maximum height to that particular position. So that means here this particular ball has started from this particular position. It has reached the maximum height in 3 seconds and it has started falling down. So that means somewhere here when it reaches, it will be taking 4 seconds time. So that means it has taken 3 seconds to reach the maximum height, and in another 1 second, somewhere at this particular position, this ball has reached. So this distance is h1 and this entire distance is h. Now you have to calculate that particular h1. So now h1 is the distance traveled by the stone from the maximum height to that particular position. So maximum height to that particular position means here initial speed becomes 0. That means here let's call this initial speed as u1 becomes 0. So now here u1 becomes 0. The initial speed becomes 0 because now we are considering the motion from the maximum height. So from maximum height means in maximum height it has stayed for some time, for few milliseconds. That means its initial speed is 0 and the time is 1 second. So that means new t1 is 1 second and initial speed is 0. So here this t1 is the time taken by the ball from the maximum height. So time taken by the ball from the maximum height. So this is the 1 second is the time taken by the ball from the maximum height to reach the position, which we have to calculate. So to reach the position after 4 seconds. So to reach the position after 4 seconds. So after 4 seconds it has reached some position. So that position it has reached after 4 seconds. So in first 3 seconds it has reached the maximum height, and in next 1 second it has reached certain position, because total time is 6 seconds. To reach the maximum height it is 3 seconds. From that 3 seconds, that from that maximum height it has taken 1 more second, that will be total 4 seconds to reach a particular position. So from maximum height it is 1 second. So that's why t1 is 1 second, u1 is 0, because at maximum height it stays for some time. So that's why its initial speed from that particular maximum height you have to take, that is u1 and that is 0. So this is initial speed. So this u1 is initial speed at maximum height. So this is the initial speed at maximum height. So now you can write the equation of motion. So now you can write the second equation of motion, where second equation of motion is distance s is equal to ut plus half at square. But here in the place of distance I'll take h1, because it has reached this position after 4 seconds. So that means it has reached h1 position from the top. So this distance is h1. The total distance is h. So that's why h1 is equal to u1 t1 plus half g t1 square. Here I am taking plus g because here now it is traveling towards the earth's surface. So that means it is traveling with the gravitational force of earth. So that means it is not traveling against the gravitational force of earth, it is traveling towards the earth's surface. So that's why I am taking plus g u1 t1 plus half gt square. So h1 is equal to, what is u1? u1 is 0, so this entire term becomes 0. So you have half g t1 square. So what is t1? t1 is 1 second. So h1 is equal to 1 by 2 into 9.8 into 1 second. So that is 1 square. So now h1 is equal to 9.8 divided by 2, that is equal to 4.9 meter from the top. So here 4.9 meter from the top, if you are considering, that is the position where this particular stone has reached. So what is the total height? So the total height is 44.1 meter. So 44.1 meter is the total height h, and h1 is equal to 4.9 meter. So that means here this h1 is the position from the top. So position from top. So from top towards that position, the height is 4.9 meter. Or you can consider h minus h1. So h minus h1 will be 44.1 minus 4.9. So 44.1 minus 4.9 will be 39.2 meter. So this also can be the answer, but this is from bottom. So this answer is from bottom and this answer is from top. So now here I have two different answers. So this particular answer, if you are writing, that means 4.9 meter if you are writing as answer, then that is the position from top. If you are writing 39.2 meter, then that is position from bottom. Coming to the 19th question, here they have asked, in what direction does buoyant force on an object immersed in a liquid act? So whenever a particular object is immersed in a liquid, there will be a buoyant force acting on that object vertically upwards. So here the answer is vertically upwards. So if you want more explanation about buoyant force and things like that, you can refer my previous video where I have explained what do you mean by buoyant force and how that acts on objects which are immersed in a particular liquid. So here the direction they have asked, so direction will be vertically upwards. So whenever the object is tried to immerse inside a particular liquid, then that liquid offers force vertically upwards, which is known as buoyant force. Coming to the 20th question, here they have asked, why does a plastic block which is released inside water will come and float on the surface of water? Why does plastic block do not immerse inside water? It will just come to the surface of water. That is because density of plastic block, so density of plastic block is less compared to the density of water. So is less than, so it is less than density of water. So that's why this particular plastic block will experience the buoyant force applied by that particular water, and it stays at the surface of the water because density of plastic block is less than density of water. Hence plastic block cannot overcome the buoyant force of water and it cannot drown inside water. So density is the main player in this particular 20th question. So here they have given mass of a particular substance, that is 50 gram, and they have given volume of this particular substance, that is 20 centimeter cube, and they have given density of water. So density of water, is equal to 1 gram per centimeter cube. So 1 gram per centimeter cube is the density of water. Now they have given mass and volume of a particular substance which is actually put inside that particular water. Now you have to tell whether that object or that particular substance will sink or float on the water surface. So in order to do that, we have to understand the density of this particular substance, because in the previous question I have told if density of a particular object is less than the density of water, then it will float. Hence here in plastic block case, density of plastic block was less than density of water. Hence this particular plastic block was floating on water instead of drowning. So similarly, this substance density also you have to calculate. In order to calculate density, we know the formula is mass divided by volume. So what is the mass of this particular object? That is 50 gram, and volume of this object is 20 centimeter cube. So 0 0 gets cancelled with each other. 2 1s are 2, 2s are 4, 1 will be remaining. So now you can put decimal point, it will become 10. So 2 5s are 10. So 2.5. So density of this substance, so density of substance here, it is equal to 2.5 gram per centimeter cube. So 2.5 gram per centimeter cube is the density of substance. So that means here 2.5 gram per centimeter cube is greater than 1 gram per centimeter cube. This is density of water and this is density of the substance which is put inside this water. So that means here substance has more density than water, therefore substance will sink inside the water. So substance will sink inside water because of higher density. So you can clearly see here density of this substance is 2.5 gram per centimeter cube and density of water is 1 gram per centimeter cube. Hence this particular substance will easily drown inside the water or sink inside the water and settle at the bottom surface of the container which contains water. Coming to the 22nd question in this particular exercise, here they have given volume of a 500 gram object. So here they have given mass of a particular object as 500 gram and volume of this object is 350 centimeter cube. So here also you should tell whether this will drown or float on the water surface. So here again density of water is 1 gram per centimeter cube. So density of water is equal to 1 gram per centimeter cube. This is also they have given. Now you have to calculate density of this particular substance. So I'll write that as ds. ds is the density of substance, that is equal to 500 gram divided by 350 centimeter cube. I am just doing mass by volume. So 500 gram divided by 350 centimeter cube is there. So 0 0 gets cancelled with each other. So 5 7s are 35, 5 10s are 50. So here 7 is there. So 7 1s are 7. 7 1s are 7. Point you can take, so 3 will be remaining, so that will become 30. So 7 4s are 28, 2 will be remaining, 2 will be remaining, so that is 20. 7 2s are 14, so 6 will be remaining, 7 8s are 56. So it goes on like this. So approximately it is 1.43 gram per centimeter cube. So that means here density of substance is more than density of water. So here density of substance is more than density of water. Therefore, this substance will sink in water. So substance will sink inside water. So here also in this case also density of this substance is more than the density of water. Hence the substance will sink inside the water. So in the same question they have asked, because putting this object into the water, certain amount of water has got displaced and you have to calculate mass of that particular water which has got displaced. So for example, if this is a container and if this container is completely filled with water and if you are putting one particular substance which has volume equal to 350 centimeter cube, then this particular object, it is drowning inside water. That means completely it is going and settling inside water. So now if this object has more density, here we have proved that this particular object has more density than the density of water. Hence this object will completely immerse inside the container and it will be drowned inside this water like this, and it will occupy certain volume inside water. So it has occupied certain volume inside water. So this much amount of volume of water will be flown outside. So that much volume will be flown outside. So now volume of water flown out, so volume of water displaced, instead of taking flown out we can take water displaced is equal to volume of the substance. So whatever the volume of substance is there, so that will be equal to the volume of volume of water displaced. So now you have got the volume of water displaced, so that is equal to 350 centimeter cube, because here volume of water displaced is equal to volume of substance, hence volume of water displaced will also be equal to 350 centimeter cube. You have to calculate mass of this particular water which has got displaced. We know density of water is equal to mass by volume. So this is the volume of water displaced. So this is the volume of water displaced, which you will be taking as V, which will go to the LHS. So it will become dW into V is equal to mass. So mass M is equal to, what is the density of water? Density of water is 1 gram per centimeter cube. So 1 gram per centimeter cube into what is the volume of water displaced, that is 350 centimeter cube. So here centimeter cube gets cancelled with each other. So mass is equal to 1 gram into 350. So that is 350 gram. So 350 gram of water has been displaced. So 350 gram of water has displaced. So now we have come to the end of this particular gravitation chapter. So if you want to understand more about gravitation chapter, then you have to go back to my previous videos and refer all the videos one by one, and also all the videos related to exercise questions one by one, so that you will have better idea about this particular gravitation chapter which is there in this 9th standard science subject. So this is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.